Welcome back to Low Stress Math with Mrs. Bono. We are in Book 3, Chapter 7, Lesson 5, proving that a triangle is a right triangle. Now, the whole Pythagorean theorem started because people were using the 3, 4, 5 rope. Remember the rope stretchers? They were engineers back in Egypt. And they were using those 3, 4, 5 triangles to make right angles so that they would have a stronger structure. So this only works on right triangles. So you can use the Pythagorean theorem backwards to prove that a triangle is a right triangle. So let's start with the word Converse. Now I know you think Converse is a sneaker, which is why I put the little sneaker there. It's to help you remember that Converse is the name of what we're doing. Converse is really the opposite. So normally we have a right triangle and we're trying to find a side, like a leg or a hypotenuse, but the converse, the opposite of that, is to have the sides and see if they work to prove that something is a right triangle. So here's the converse of the Pythagorean theorem. If the sum of the squares of the lengths of the two shorter sides of a triangle is equal to the square of the length of the longest side, then the triangle is a right triangle. If a squared plus b squared equals c squared, then the triangle is a right triangle. Yeah, that's the converse of the Pythagorean theorem. So let's see if it works. Let's try the one that we know is going to work, the 3, 4, 5 right triangle. So always C is the longest side. A and B are not going to matter. So even if they're not in the correct order, C is always the longest side. So A squared plus B squared is C squared. Yes, you have to write the formula. 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. And it's true, 9 plus 16 is 25. That equals 25. So, do these three lengths, numbers, create a right triangle? Yes, they do. Yes, 3, and it's often written like this, 4, 5 is a right triangle. All right, let's take a look at the next one. A squared plus b squared equals c squared. Again, A and B don't matter, but C is the longest of the three sides. So 7 squared plus 9 squared equals 12 squared. 49 plus 144. Oh, that's not true. Why did I write that? I was looking at the 12, noticing that I forgot to write the square. That's the 144. 9 squared is 81, and I know that, and you know that, and I need my whiteout because that was a boo-boo. (81). 1 plus 9 is 10. 90 plus 40 is 130, which is, of course, not equal to 144. So none of these are equal. So this is no. 7, 9, 12 is not a right triangle. So let's take a look at the next one. Oh, look at that, decimals. Ugh, definitely need my calculator for those. I mean, these are head ones, but this is calculatoring. A squared plus b squared equals c squared. 7 6/10 squared plus 11 and, oh, look, me, I was about to make that mistake I keep telling you not to make. This is A and this is B, but C is the longest side. 8 4/10 squared, is that equal to 11 5/10 squared? I don't know, but I do have a calculator to help me find these things out. So, one more time, a little review. To square a number, you just put the number in, 7 6/10, and hit this button right next to the 7, which is the x squared, doop, and enter, you get 57.76. And then 8 4/10. Again, hitting that x squared button, 70 5600. 70 5600. Is that equal to 11.5 squared? 132.25. Let's find out. We'll have to add these two numbers together. So clear that up, and let's do this. 57 and 76 plus 70 and 5600 is 128 and 3200. It's close. But it's no cigar. It's not equal. So, no, not a right triangle. Let's take a look at this next one. Again, C is the longest side. A and B are going to be whatever the other two sides are. Be careful. I wasn't careful, and I messed up, and I had to go back and fix it. You're smarter than me. Your brains are young. So 12 squared plus 9 squared equals 15 squared. 144 plus 81 equals 225. All right, now I'm going to admit it. I could add that in my head, can't I? 1 plus 4 is 5. 8 plus 4 is 12. Oh, wow, it works. See, I didn't need my calculator and put it over there. So that is, yes, it is a right triangle. Okay, so things to be cautious. Make sure you use the formula. Make sure that you put a not equal sign if things are not equal. I don't know why I made the Pythagorean theorem not equal, because it is. That's always true. So we don't know. But things are not equal. They're not equal. It's either no or yes, and make sure the longest side is C. All right. Now look at these. Your turn. You try those. Go ahead. No, wait, I'm lying. I was going to tell you to try these down here. Let's do these together. Okay, A, B, C. How did I know it was C? Because 26 is bigger than 24 and 10. A, B, C. 8 is larger than 6 and 4. So A squared plus B squared is C squared. 10 squared plus 24 squared is equal to 26 squared. 100 plus some number I don't know. I just like 500 and something. 24 squared is 576. So yeah, it was close. Is that equal to 26 squared, which is, I think, 676? It is 676. Look at me all remembering stuff. 676 is equal to 676. It checks. This is yes. 10, 24, 26 is a right triangle. Woo, that's good. Now, let's try this one. A squared plus B squared equals C squared. And 4 squared plus 6 squared equals 8 squared. Let's see, 4 times 4 is 16 plus 36 equals 64. And up, this is not going to work. 30 plus 10 is 40. 52 is not equal to 64. Not a right triangle. Wow, my handwriting is never good on a Monday morning. All right, not a right triangle. So now it's your turn. Turn off the video and practice the problems. You can do this. I'll wait for you. Did you pause? Did you do the problems? You're never going to learn math if you don't do math. So, A, B, C. C is the longest side. C, A, B. C is the longest side. A, C, B. C is the longest side. C, A, B. C is the longest side. I'm doing that first so that when I am in the middle of doing the problems, I don't mess it up. You know me. Check these things first. A squared plus B squared equals C squared. 6 squared plus 8 squared equals 15 squared. 36 plus 64 equals 225. Is that true? Yes. Oh, wait, no. 90, 100. No, 100 is not equal to 225. Not a right triangle. Very big no. This one might be, though. Let's try it. A squared plus B squared equals C squared. 15 squared plus 11 squared equals 17 squared. 225 plus 144 equals, I don't remember. My poor little feeble brain. What is that? 17 squared is 289. Nope. Because this is already 225, it's not going to work. So 369 is not equal to 289. Not equal, not equal, not equal. This is another big no. Not a right triangle. Interesting. Again, make sure you have them in the right order. A squared plus B squared equals C squared. 15 squared plus 36 squared equals 39 squared. 225 plus no idea. So 36 squared equals 1296. That's a big number. But you were going to write it wrong. Got that little Monday morning brain going on here, Bono. 1296 equals 39 squared. What is that? 1521. Might work. We don't know. So now I have to add those two numbers together. 225 plus 1296 is 1521. It worked. Yay. You know, one of the things I really like about the converse of the Pythagorean theorem is that I don't have to square root anything. I just have to square and add. Much easier. This is going to be a giant yes. It is a right triangle. And what have I got here? My bet is no, but I'm not going to say that until after I do it. So A squared plus B squared equals C squared. 5 squared plus 11 squared equals 13 squared. 25 plus 121 equals 169. And 146 is not equal to 169. Wow, a lot of no's today. This is a big no, not a right triangle. All right. I think you're going to be good at this. This is not horrible. Now, my favorite part, last page of the booklet. You thought I was going to say my favorite part was Pythagorean triplets. But you know what? I do love Pythagorean triplets. So here's my thing about Pythagorean triplets. This table shows several sets of Pythagorean triplets. Any set of 3 whole numbers that satisfy the Pythagorean theorem. The table has them and prove these numbers are right triangles. So we only have to do 4 problems. And they're even labeled for us. So let's give them numbers. 1, 2, 3, and 4. All right, so 1 is 3, 4, 5, which is a squared, oh, sorry, number 1, plus b squared equals c squared. 3 squared plus 4 squared equals 5 squared. 9 plus 16, we already knew this one, is 25. 25 equals 25. That's the proof. When it says prove it, that means do the Pythagorean theorem. Let's prove number 2. Again, I'm still writing that formula. Every time you use a formula, it's a good habit to keep writing it down. 5 squared plus 12 squared is 13 squared. 25 plus 144 equals 169. 25 plus 144 is, unsurprisingly, 169. All right, number 3, didn't write it, a squared plus b squared equals c squared. Always give yourself a little extra room in case you make a mistake. 7 squared plus 24 squared equals 25 squared. 49 plus, I don't remember 24 squared. Let's do that on here. 24 squared is 576. Why can't I remember that today? It's the second time I'm writing it, but this is 225. So look, if I add 49, I get, 625, which is what that should be, not 225. Come on, Bono, 625. See, helping me find my mistakes. So that one checks, this one checks, and now the last one, which is, we're going to talk about families in a second. A squared plus b squared equals c squared. 12 squared plus 16 squared equals 20 squared. 144 plus, oh dear, what's 16 squared? I should know that. Oh, bother. I feel like Pooh Bear today. 16 squared is 256 equals 20 squared is 400. So 226 plus 144 is, there you go, 400, it worked. And 400 is equal to 400, so this one checks too. So that's how you prove it. If it says prove it, do the Pythagorean theorem. Now, it says, can you list under any other Pythagorean triplets? We're going to do what's called a family of triplets. And what you do is you take the first one, 3, 4, 5, and you double it. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So 6, 8, 10, also a Pythagorean triplet. But then if I do 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15, that too is a Pythagorean triplet. 4 times 3 is 12, 4 times 4 is 16, 4 times 4 is 5, 4 times 5 is 20. Oh, and that's this one right here with the proof right there. You can just use your calculator and prove those. Every one of them is a Pythagorean triplet. But you can do that for any of them. 5, 12, 13 times 2, 10, 24, 26. Now that was back here on this page, wasn't it? Yeah, here it is. 10, 24, 26. It's also proved that it's a right triangle. And 5, 12, 13 is how I knew this wasn't a right triangle, because 11 is not 12. I knew that wasn't going to work before I even did it, because 5, 12, 13 is the Pythagorean triplet. 15, 36, 39, and you could just keep going with that. You could do it with this one. 7, 24, 25, 14, 48, 50. Those are the, I could just keep making up triplets. by multiplying the ones I know are triplets. You can do this. It's not that bad. I'll talk to you soon.